Hi, my friend. Welcome to my lesson. It is about lossy data compression. This is also important than lossless data compression. And at that point, maybe you'll think how we can do that with the lossy. So, what is this lossy data compression? We will process all of these topics with the subtopics too. So I don't want to extremely lot to you, but step by step we will go, okay, through our experiment. Let's come here and let's say lossy compression and put there this with the red, and this is subtopic of it, and let's do line here. Yep, it can stay like that, and let's get started from this point. Let's start to say lossy compression algorithms are compression algorithms are techniques that reduce file size. Yes, file size by discarding the less important discarding less important discarding less important information, discarding the less important information. This is good, really. It is helping you too much sometimes. So for some situation, let's write more about it. Let's say in that point we have two important things: the humans' ears or human eyes just can see brightness carefully, but the humans' eyes are not seeing too much good for too much good colors, so they can't separate the color quality too much. What is the so color quality, pixel quality within this color closest? Okay, now I will explain you all of this situation. Let's go step by step. So, but human can separate the brightness. Brightness is too much important. Brightness. If you take up brightness and if you reduce it, then people really can understand. If you increase or if you decrease, people can understand brightness. But color will be a little difficult for human eyes. I mean, nobody likes losing information. Nobody likes losing information. But some types of files, but some types of files mhm, are so large that there is just not enough space. There is just not enough space to keep all the original data. To keep all the original data. This is good. So it's just some types of files are really too much large, so large that there is just not enough space to keep all the original data really. Just we will do all of them together. Then you can say plus let's say plus. We didn't need all that. We didn't need all that all that data in the first place. Data in the first place. So let's say that's often the case with photos. Often the case for photos. Often the case with photos. Sorry, not for photos. With photos. With photos, videos and audios. audios, audio recordings. Sorry, Re- recordings. So let's say files that try to capture capture files that try to capture the beautiful complexity of the world of the world of the world we live in. Yes, the point here, that's often the case with photos, videos, and audio recordings, files that try to capture a beautiful complexity of the world we live in. This is the point here. So, just for some detail, we will do something. Let's come down. Mhm. Computers can capture. Computers can capture capture on incredible amount of detail and incredible amount of detail in a photo. But how much of that detail, how much of how much of that detail can that detail can humans humans actually perceive actually 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 perceive. This is the key point because we can't see with our eyes too much detail in images. So we can't see all of this columns, rows, about pixels. We can see the big picture. We can't see the small pictures in the image. For that we can we can compress some kind of fixed pixels there. We can average them so we can do some operation in the small places per se. As it turns out, as it turns out, as it turns out, there's lots of detail that we can remove. There is lots of detail. There is uh, a lot of detail that we can remove. Yeah, really, we can. Lossy compression algorithms are lossy compression lossy compression algorithms are um, all about figuring out all about figuring all about figuring out clever figuring out clever clever, sorry, not the word clever, ways to remove detail ways to remove detail without humans noticing. Yep, without human humans noticing. This is the important noticing. This is the key. So if the human notice it, if it sees, so if the human see, then of course we can do again. One person quality is also sure, but if you don't, so for the downloading, I mean, if you download some file with the small quality, it will download very fast. It's banned also about your uh, internet speed. If we reduce the quality, then you can download it very fast. But if the quality is high, then your computer, so your internet speed is too much important. It will take lots of time there. The quality is parallel with the speed of your internet. Noticing, I mean, too much. So come down. Let's say, for example, for example, here's a photo of a cat. Here, a photo of cat. Of Here's a photo of cat in a hat. In a hat. Let's look at. I will show it you now. Where is the files? Right here. You can see with me. Yeah, let's come to downloads. Yep, the cat one. Where is the cat one? It's called cat one. Yes, that one. So now what happened? This cat is very big. Let's move it. Wow, this is crazy big cat. Yes, let's. Yep, this is our cat. Now we will look all detail about this cat. Also, we can look little pixel of cat. Now let's see details here. Have you see? Uh, yes, this is the pixel details. Have you see? There is lots of colors. So in detail in it. Let's look. Amazing colors there. So too many colors. Okay. This, so if you look, this place is not black. If you go in details, you will see lots of color there. Let's look to this place in blue. Maybe let's come in blue. If it is blue, then we will understand this is blue, but it is maybe, yeah, we have white inside blue. We have some different little different colors. Anyway, this is the detail of photos. Okay, images. Now let's say in that point, let's come a little down, maybe close this point. Yes, to here. Okay, let's say here's that some photo. Here's that some photo, but compress it to compress it to half half the size. Half the size. Yes. Let's look to this is not some, sorry, this is same. Yeah. But compress it to half the size. Let's look what it will look like that. What it will look like. Where is the cat 2? Let's say cat 2. It is that. Yes, this one. Let's take it here. It will be again big, I think. Oh, crazy cat. What are you doing there? Yes, this is our other cat. It's the same cat, and this is really just half. Okay? It's really half, not different. Let's go there. Okay. This photo is the half the size. Okay. What is different? Really, do you notice? Did you see here some detail in the pixels? I think no. But if you see, this is half of this image. If so, you can think like, just think we have here 250 to 250 pixels. It will be like 125, 125. What did you understand here? Maybe we averaged it, all details. Okay, let's come to other place. What we will say in that point, let's take again pencil and come down. Yes, let's say, can you tell the difference? Can you tell the difference? If you can tell me, just write me a comment. At a quick glance, so at that point, and in that point, at a quick glance, quick glance, yep, I can't, I can't. And even if I could, and even if I could with more, if I could with more effort, it still be worth saving. It still be worth saving half the disk space, half the disk space, which is amazing. Let's explore some of the clever ways. Let's explore some of the clever ways to ways that ways that lossy compression algorithms, lossy compression algorithms, compression algorithms remove detail to remove detail tile the detail to reduce file size. Yes. So this is the point. Just this is the important. Half the disk space. Why we will put lots of things there? Just we can remove some less important details. So maybe it is important if you are interested with some graphic, with some kind of photographer, or if you are something like that, it is important. But if you are sending some images, if you want to see big image there, a magnetic or image, then for the download or for some kind of this stuff, we can really take half size of this image. I mean, with the pixels, we can decrease them. Yes, in that point, with not with, in that point, we have a model. What is this model? Keep the brightness, average the color. Let's do it together. At that point, just come here. This is our subtopic. Let's say images. Start with images, videos, then audio recordings. Anyway, start with it. Keep the, let's say, keep the brightness. Yes, brightness. Yep. Average. Average. The average. The color. Okay, let's take it into the blue color. So blue. What is it? Right here. This is too much blue. Let's come a little right. It's all the way. Okay. Like that. Okay, this is our subtopic. Let's come here. Let's start the writings now to here. Okay, let's do it. Now we can say, now let's take it a little back to that point. Yes. And then let's put my earplug to here. And let's start to write. The human eye, the human eye, human eye is better at perceiving perceiving differences in brightness than differences in color than differences in color. Yeah, this is important point, friend. Just solve this point. Human eyes not get on color too much. I mean, about details, but about brightness, really we can separate it, so we can understand, we can notice it. Color, let's start again, continue. I mean, a compression algorithm can take advantage. A compression algorithm algorithm can take advantage advantage of that fact by keeping of that fact by mm, fact by keeping the brightness while the brightness while reducing the amount, reducing the amount of color, the amount of color. Yep. Information. Okay. A process known as chroma. As chroma. Don't forget this name, chroma. As chroma, right? Subsampling. Subsampling. Yes. Subsampling. Let's let's try it. Let's try it on the photo of the cat. Let's try it on the photo of the cat in the hat of the cat in the hat. The first step is to separate. The first step is to separate. Yep. The brightness information from the chroma. The brightness information. The brightness information from the chroma. Yep. First, we will separate this brightness from color. I mean, chroma means color, like that. You can think. Let's come down in that point. Yep. Let's say here's the brightness. Here's the brightness. Right. Here's the brightness. Only version of the photo. Brightness. Now you will see what is that. Let's come back to here and let's say cat 3. This one. Let's bring it here. I think it will be again very big. Crazy cat, you're very big. I will tag you there with the small pixels, right to here. Okay, this is the only brightness version. Okay, there is no color, no anything. This is just brightness. So I mean color, but this is the brightness. I mean without brightness. Look, this is with the colors and with the brightness. Now it is only version. Okay, brightness only version. And then let's come to down and let's say maybe I can do things here to tag a reference from this point. Yes, to here. Let's come down and let's say here's the chroma only version. So it is also only color. You can think like that. The first one is with the brightness, the other one with the color, It will be cat 4. Let's tag it here. Yep, this is without brightness. Yep, we just separated. Have you seen what we did? Look. Let's do it a little bigger. Yep. This is with the brightness, only brightness. Yeah, this is the only color. only color. So this point hat, and this cat, eyes, maybe you saw it, eyes in eyes. Do we have color? Okay, we'll speak about details, okay? So there is no brightness, just we tag the colors from that point. Yep, this is with chroma, other one with the brightness. We just separate it. Now we will work with the color point. We will average. Now I can show you. Let's think from that point. Maybe let's come. Maybe that point. I mean, with the blue hat. Let's go in it. Yep. Let's go in a detail. Just think we have here one. So in that point, let's. I think it will be very big, but just I will try it. Oh yes. Just think that this one, that one, and it is very big. This pixel, this pixel, and this pixels. Just think little bit different. If we go detail, they are different. We will take average of them. Then really it is that lossy. So lossy info, lossy data. Just you're reducing colors, you're just taking them into one point, that you so reducing the file size, it means. Okay, we will speak about that. So I don't want to load your brain too much. We will speak about details later. So let's say at that point, take the call like that, and let's take it, close it. Yep, here. Let's come down. And let's say this photo is interesting. This photo, this photo is interesting because because the cat and the chair, the cat and the chair The cat and the chair are both fairly colorless. Colorless. Right. Color no have there. The blue of the hat. The blue of the blue of the. Oh, what I did. I got screenshots. Sorry, guys. Blue of the hat is what stands out. The hat is what stands out in the chroma. Is what stands out in the chroma version. In the chroma version. Yes. Now let's say perhaps all own we should own all own perhaps let's tag in parentheses perhaps we should we should all we should all own black and white cats, black and white cats. Save disk space. Save disk space. Let's zoom into an 8 2 pixels to block of black of chroma, block of, yeah, block of chroma version, block of chroma version, chroma from the left eye, from the left eye. Okay, in that point, let's check the CAD image file 5. Where is the 5? Where is the 5? I'm not seeing it. Oh, it's okay there. Yep, it is not too much big. Okay. Now it is very big. Let's come back to that point. Bring it also there. No, do it and also tag this. Oh, yes, I need to restore it here. Let's tag to in that point. It's okay. Let's go in detail. Let's go a little left. Okay, it's this. Okay. So what is it, This 8 times 2 pixel, this 1, 2, 3, 4, 5, 8, and 2 from this place. So I mean rows, 8 rows. So 2 rows, 8 columns here. So it is that point, this point, left eye. In left eye, we have that point. We're just looking in here. Let's go in detail. Yep, it is very, maybe I can do something like that. Yes. Yeah, in that point, the some point here, okay? Now we are looking in that eye, I mean, left eye. This is the left eye and left eye at some point. So what we will do in that point, we'll take average of this 4 and again this 4 and again this 4 and just we will put there 4 pixel, then then 4 8 it's 16, then 16 pixel. Just we will reduce 16 pixel to 4 pixel to represent that image again. So this is the lossy compression. Okay, you can understand like that. It will be very easy to cover it in your brain. So let's say for it, each of those pixels are slightly, each of these pixels are slightly different chroma values, different chroma values. So there are 16 values total. So there are 16 values total. Yeah, we can average each. We can average each 2 by 2 block and set, block and set, block and set. It's color to the color to the average so that there are only 4 values, only 4 values total. I told you we will reduce this 16 pixel. I mean, it is normally 8 by 2, so it's going 8 like that, 2 like column, 8 is rows. Now we will do 2 by 2. It's 2 rows. I mean, 2 pixels to here, 2 pixels to down. It will be so that one. I mean, I think you got what I did, what I said. This point, 2 by 2 pixels. We will tag average of this two color, and just it is will be 1 pixels in that point. Again, the other one will be 1 pixel, and it is just will be 4 values in this point. Okay, you can understand like that. So if we implement all of the images that stuff, then we will reduce lots of space there. We will save disk space in that way. And then now I will show you what we did in that point. Again, we have images here. 6 is that. Yeah, now it will be like that. Look what we did. Maybe, yeah, just think. We just tagged, we just got this point, average of these colors, and we bring it into this point. We just averaged it. So we just tagging four closest color, so they are very close to each other. So we just tagging them to one values. I mean, one value in a value. We compressing it, and then let's say, let's come down to here. The results look quite similar. The results looks quite similar. Looks quite similar to the original. You don't understand. You didn't understand anything. Yes, you didn't notice because why? Because this is professional way to reduce something from there, but it has a quarter of the original color information, quarter of the quarter of the original color information. If we apply that to if we apply that to the entire image, we can save a lot of space. We can save a lot of space without affecting affecting perception much. Yes, you can manipulate your perception with the colors, but without brightness. I mean, so brightness will be dangerous for that point. Chroma subsampling. Chroma subsampling is a process used in many compression. Is a process use it in many compression algorithms, compression algorithms that deal with images, that deal with images, including the including the file, popular file formats, which is JPEG and MPG, PG, MPEG and JPEG. So, what is the chroma? You got it. What we did, right? Chroma is a color, okay? You're just separating brightness first. It's coming like black and white images without brightness. Then so you're looking in the color, what we have color there. So without brightness, we know what we have and how we can reducing. With manual also, I will tell you all of this detail. So we just know first look the images and just tag the brightness from there and look into the color. So separate color, separate brightness, and there is just we have framework. It is there is frame in frame anything. Okay, just play with the color, reduce the file size with the colors. I mean, we impressed, we just implement there some module. You got it like 16 pixels. We reduce it the four values. I mean, we got average of them. Then what we did, we put again in the frame. Again we put the brightness there, and it is all. We just manipulate your perception with the colors. Yes, those algorithms are user process. Those algorithms are also use a process. Call it use a use a process. Call it great. It's great. Cosine. Cosine transform. Yeah, those algorithms. I think I did. Yeah, which is a saying DCT, like D, C, and T. Discrete cosine transform to simplify the details. To simplify the details in the brightness. The details in the brightness also. Really, brightness. Brightness. Brightness layer. Yes. If you'd like to learn more on, so if you like to learn more, really, if you want, you can go to search discrete cosine transform. You can look for image processing and some kind of stuff here. really you can learn more about it. So let's look in some detail. What is that? Yep. uh, this is some math operation also. Yep. Yeah, it is amazing formula here. Yeah, look at, we go detail of it in it. Oh, we come back, maybe need to come back. Yeah, look the detail here, just tagging brightness up to come back again. We have some formula in math. Let's look to here, the horizontal and vertical place. It's really, one is, have you see what happened here? 2 and 2 and 3 and 3 all the time is looking like same after all place. It's like matrix, complex matrices. It's crazy, right? You can search this algorithm, okay? You can really check it. This is some images, you can look details in it. Have you see something? Yeah, you're just tagging the car brightness to this point and you're working with it. Anyway, this is some detail. You can look also for chroma. I mean, say lossy, compression. It's compression, chroma, subsampling. Yes. Also, there is some point. You can search in that point this informations. Oh, this is some PDF file. Lossy compression in the chroma subsampling process, parallel pattern. Introduction. Data compression is the art or science of representing information in a compact form. And say there are, yes, this is amazing uh, point here. Let's look the detail here. This is chroma subsampling. Tagging brightness, you're tagging brightness, you're tagging colors, you're tagging effectings, you're just separating them, then you're just reducing something there, and really all of it is. So it's helping you to work with it. Okay. If you want, you can search them too. Let's close this place. And it is all. The other topic will be all right, let's come here. Yep. Other topic will be audio drop drop, the inaudible sound, inaudible sound, right? Inaudible sound. Yeah, and this is for sound recording, I mean voice recording, sound recording. And then we have for videos some information. Yes. Let's wait at that point. We can start to audio drop the inaudible sounds.